Alright, welcome to this ninth tutorial. This is Liwali Mshokawanje, and today we won't go into nested for loops. We're going to look at how to use loops with if statements. I would like to show you how you get to use those. So we had looked at loops in our earlier tutorial. You can check that out. So we're going to write a program that's going to request a number from the user. Once the user provides that number, it's going to print out all the even numbers that are in between what? Two divided by 2 will give us a 0. We'll print out the 2. I plus 2 becomes a 3. 2 divided in what? 2 divided in 3. That's going to totally not give us a 0. So we won't print out 3. I becomes 4. 2 into 4 gives us a 0. So we print out 4. I becomes 5. 2 into 5, that's not a 0, we don't print it out. I becomes 6. 2 into 6, that gives us a 0, we print out what? 6. So we continue doing that until we satisfy this condition. We talked about the condition back in our previous tutorial in the for loops. So once we get to 20 will be equal to num. We're going to go in and carry out this code. But once we say and I becomes 21, we'll say is 21 less than 20? No. Is 21 equal to 20? No. Then we stop here. So that's what basically happens. So this is a simple program to print out even numbers in C++ by using a loop and an if. You can also use a while for this case. So now let's look at a program where we print out prime numbers only. The user enters a number and we're going to print out all the prime numbers in that number. So this one we'll use a for loop, and we're going to use a nested nested ifs. Yeah. So here's the thing: we're going to maintain the same program. The user is going to provide the number, and when the user provides the number, we're going to still count through. And when we count through, we're looking to provide only prime numbers. We only want to print out prime numbers. So how do we print out the prime numbers? This is what we do. What's a prime number? A prime number is anything that's divisible by 1 and itself. That's a prime number. Anything that's divisible by 1 and itself, that qualifies to be a prime number. So now let's think, what is 9 a prime number? No, 9 is an odd number. So all odd numbers are prime numbers. Get this straight: all odd numbers are prime numbers, but not all prime numbers are odd numbers. That's just how it works. 7 is a prime number and 7 is an odd number. See that? But 9 is an odd number and 9 isn't a prime number. See that? All odd numbers are prime numbers. All prime numbers are odd numbers, but not all odd numbers are prime numbers. Get it again, please. I'll continue saying this until it sinks in. All prime numbers are odd numbers, but not all odd numbers are prime numbers. So hope that sinks in. So the first thing that we do here is we filter out from the numbers. We're going to collect the odd numbers. Let's collect the odd numbers first. So let's collect the odd numbers. What's the property for an odd number? Whenever an odd number is divided by 2, we get 1 as the remainder. So in our for loop, we're going to say if I modulus 2 and the remainder is 1. So first of all, we collect all the odd numbers. So let's check if it's really giving us the odd numbers. I'm going to say I. Let's see how we see for collecting the odd numbers here. I'll say 20, we get the prime numbers 1, 5, 7, 11, 13, 17, 19, which are correct, but they're all divisible only by 1 and themselves. 1 is divisible by 1 and itself, 5 1 and itself, 7 1 and itself, 11. But what about 3? Doesn't 3 qualify to be a prime number? 3 is only divisible by 1 and itself, but it's not here because of the condition here. Was saying when 3 is divided into this, the value in I, and it's not in 0, that's when it's able to print out. But if I has the value of 3, meaning 3 divided into 3, we're going to get a 0, meaning this will be false and we won't print out 3. This is where logical operators come in. So with logical operators, we're able to say or I equal to 3. Once we say this, so either one of these conditions, as long as one of these conditions is true, we're going to carry out this this piece of code. So let's run this. I'll say 20, and we get 3. 3 is now appearing among the prime numbers, which is true. So if we build and run this again, if I say 40, we're going to have all the prime numbers within 40. So 1 to 37, and that's pretty much correct. Yeah, that's pretty much correct. So there we have it. Now this is how we print out the prime numbers. So we've seen how to print out even, odd, and now we're printing out the prime. So pause this program, look at the code, try to understand it. We have the for loop, we have the if. Here, in fact, here we're having nested what? A nested if, and we talked about that in the previous tutorial. So try to go through this work again and again until you understand exactly what's going on, understand the loop and how it's used. Next tutorial we'll be talking about nested loops. We'll talk about nested loops and see how to manipulate and get to use them. I hope I see you next time. Right now, this is bye. Have a good night. I don't know what time you're watching this, but just enjoy your time.